Hello students, welcome to the next lecture on the inner product space. Today I will explain you the concepts of the inner product space with some examples. Myself Dr. Harish Garg, you can follow and subscribe my YouTube channel. What we have discussed in our last lecture, we learned the objectives of this new lecture series inner product space. Now before I start directly to the inner product space, let me give you some motivation how you can think about the inner product space in a very easy manner. Let us think about any vector, any point in the xy plane or any vector in the xyz plane. Fine. That means you can think any vector in the R cube or in the R2. So I consider the point A which are x distance apart from the O. Then we can say OA is my vector. First of all, OA is my vector, not a scalar. Fine. And if I called x is my length of the vector. So can you find the length of the vector? Definitely you can use the distance formula and I can define the length of the vector is called as norm. Fine. Whenever we call as the length of the vector, then it is called as the norm of the x. If I say x is my OA vector, then we can define the norm of the vector. Norm is denoted by these two perpendicular lines. If I write as a y, then it's a norm of the y. Now the second question is how you can find the length of the OA. I can define by using how you can find the length of the vector. That is, I can use the distance formula. Find distance formula between O vectors and the A point. So I call as the distance formula is root x1 square plus x2 square. Similarly, if you are talking about the 3D, that is R cube, you can define the distance formula or call as the norm of the vector is x1 square plus x2 square plus x3 square. Similarly, if you're talking about the Rn, we can define the norm is x1 square plus x2 square plus xn square and clearly say this norm is not a linear. Fine. Because of the square value, these norms are not my linear. But our target when we are talking about the inner product space, our target is to discuss the linearity. Fine. So how you can think about the linearity from the norm. So for that case, we will try to understand the concept of the dot product. Fine. So आपने elementary classes में all of you know how you can find the dot product between the two vectors. If you have the vector A, how you can find the dot product between the two vectors? I can A, B and cosine of angle, and we all knows that dot product is always the scalar value. यही होती है. However, if you define as the cross product, that will give you the vector value. Clear? So we can define the dot product by using as the standard x1, y1. Like if you have the vector -1, 0, 4, y is say 2, 1, 3. How you can define the dot product? That is the element wise multiply. You can multiply -1 to the 2. Second component 0 and 1. And the third component is 4 and 12. The answer will be 10. And make sure, as I mentioned you, the dot product is always with the scalar value, not a vector value. Fine. So once it is a scalar value, it satisfied my three basic property. And from this last case, you can easily say x dot y is same as y dot x. And x dot x is always a greater than 0 because it's a equality. Or you can simply say it's a strictly greater than 0 for all x, which is my non-zero, and x dot x is my 0 if and only if x is my 0. Fine. Now we can, because this is a scalar value, based on this scalar value, that is based on the dot product, we can define the concept of the inner product space. The inner product is the generalization of the dot product. Fine. How you can generalize them? So before I generalizations, let me give you some notations that I can use throughout my this lecture series. Wherever I have written the capital F is either the real line or the complex numbers. V is the set of the vector space over the f. F is either R or C, and the notation which we are using this value, that is called as an inner product. Clear? Make sure student f is a real, or if I say alpha belongs to the f, what does it mean? Alpha may be a real numbers or alpha may be a complex number. Fine. Now based on this notation, I can define the inner product. Look at the definition. Inner product is nothing but the mapping from V cross V to R. And we know the V cross V is my domain. Fine. And R is my codomain. If you take any element, it's a cross product, that is a relation. If you take any element of the V cross V, it maps on the scalar. Fine. So which product you can define as a scalar? That is a dot product. So I can use as x comma y, or call as the x comma y, if it satisfied my four properties. सबसे पहले डॉट प्रोडक्ट की प्रॉपर्टीज क्या थी? It must be greater than 0, and if it is a 0, then it must be 0. Fine. So x comma x is must be greater than 0 for all x non-zero, and if it is a 0, if and only if x is my 0. Or you can combine the two cases at the same time, x comma x, which is greater than equal to 0 if and only if x is equal to 0. इसका मतलब क्या है कि अगर आपका x 0 नहीं है तो ये कभी भी आपके पास 0 नहीं होगा. फाइन. और अगर ये 0 है तो हमेशा x ही 0 होगा. और अगर आपके पास किसी भी तरह से कैलकुलेशन करके ये नंबर नेगेटिव आ जाता है, देन वी कैन से इट इज नॉट एन इनर प्रोडक्ट. द थर्ड प्रॉपर्टी सजेस्टेड यू अबाउट द एडिटिविटी, दैट मीन्स x प्लस जेड इज इक्वल टू x plus z comma y is x comma y and z comma y, and alpha x comma y is alpha is outside x comma y, and the last one is a conjugate symmetric. Make sure students the most important property is the fourth one. यहाँ पे अल्फा पहले के साथ लिखा होना जरूरी है. अगर वो सेकंड के साथ लिखा हुआ देन वी विल डिस्कस लेटर ऑन. फाइन. 3-4 स्लाइड के बाद हम देखेंगे अगर अल्फा सेकंड के साथ लिखा हुआ देन व्हाट विल हैपन. अभी आप सिंपल समझिए कि अल्फा अगर पहले के साथ लिखा है then alpha will be outside. Fine. और कोई भी ऑपरेशन, any operation which satisfied these 5 properties, then the vector space V is said to be inner product space. Some special cases are there. If you consider f is my R, that means if I consider alpha is my real number, and we all knows whenever alpha is real number, what is the alpha complex conjugate, which is again the same. So that means the last property, the conjugate complex property, becomes my symmetric property. Fine. It is my symmetric property. On the other hand, you can combine the third and fourth property into the single one, like alpha x plus beta z comma y. Instead of writing only as a x plus z, I can write as a alpha and beta. Because alpha and beta पहले component के साथ लिखा है, so alpha will be outside x and y. Fine. Beta भी पहले के साथ लिखा हुआ है, so beta is outside z comma. That is called as the linearity property of the inner product. Make sure students these are my inner product, not as a inner product space. अब आप inner product space किसे कहेंगे? वो सारा प्रोडक्ट, वो वेक्टर स्पेस जिसमें ये सारी प्रॉपर्टी सेटिस्फाइड हो जाए, then that vector space is called as the inner product space. Clear? Now make sure students f, wherever I have written as a f, it is always the R or C, any one of them. If I use particular f, V is my vector space, over the R, then the inner product space is known as the Euclidean inner product space. Whenever you are using as a C, then we call as a unitary inner product space. So whenever we will discuss in our future lecture, we call as a Euclidean inner product space, it is quite obvious that f is nothing but my R. Now, some of the standards inner product space, because my vector is on the Rn. If I choose the two vectors x1, x2 up to the xn, y I call as y1, y2 yn. Then what is the standard inner product over the Rn is, because it's a generalization of the dot product, so I can use as the dot product xi y. Fine. That is a standard generalization of the dot product. If you're talking about the complex numbers, then again it's the same formula, but instead of written as a standard in a dot product, we can take it as a complex conjugate of the second component. Moreover, instead of writing as a second component, you may write as a complex conjugate of the first part. Fine. In this case, x and y are the elements of the Cn. If you are the vectors of the matrices, then you can define inner product A of the two matrix as trace of the A star. What is the A star is? A star is my conjugate transpose of the complex matrix. Conjugate ट्रांसपोज ऑफ द मैट्रिक्स ए. बट अगर आपके पास रियल एंट्रीज है तो कॉन्जुगेट ट्रांसपोज किस में इक्वल हो जाता है आपका? ए स्टार इज नथिंग बट द ए ट्रांसपोज. फाइन. सो दीस आर द सम स्टैंडर्ड इनर प्रोडक्ट स्पेस. द फर्स्ट एग्जांपल इज इफ V इज माय इनर प्रोडक्ट स्पेस. फाइन. Y इज एनी एलिमेंट ऑफ द V. यहां देखिए F दे रखा है आपको. F may be R, it may be C, and your target is to prove the linear. So linear के लिए आपको क्या प्रूफ करना है? Alpha times of the first one x1, beta times of the x2, it must be equal to alpha of x1 and so on. If I start from the left hand side, fine, f of alpha x1 plus beta of x2, I can substitute the value. That will be x. X is my alpha x1 plus beta x2 comma y. I can use the properties of the inner product. Fine. I can use my third and fourth property. और मैं second third property use करता हूं तो इसको क्या लिख सकता हूं? alpha x1 comma y, and second को क्या लिख सकता हूं? beta x2 comma y. Fine. Now I can use the fourth property. Alpha I can taken as a outside. That will be x1 comma y plus beta is outside x2 comma y. Clear? Now you can see about that. ये एक्सप्रेशन क्या बन गया आपका? इफ यू कंपेयर, यहां पे जो x लिखा हुआ है दैट विल बी द सेम x. तो ये पहली वैल्यू क्या बन गई आपकी? f ऑफ x1, एंड सेकेंड वैल्यू विल बी f ऑफ x2. हेंस f इज माई लीनियर फंक्शन. लुक एट द सेकेंड वन. हाँ, यहां पे देखिए मेन चीज. अब अगर अल्फा आपका सेकेंड कॉम्पोनेंट के साथ है, वेन एवर अल्फा इज इन द सेकेंड कॉम्पोनेंट, then instead of taken as a outside, because whenever alpha is written with the first component, then you can take an alpha as such outside. Fine. However, whenever alpha is written with the second component, then the complex conjugate will be outside. Fine. Then that means if you combine these two properties, then again it will define as a linearity, but you can see it's a complex conjugate we call as an anti-linearity function in the second slot. Make sure in the first slot we have seen alpha is right in the first component, it is outside. Fine. While the first values remain same, you can write as xy and xz. The proof is a very simple. If I start from the left hand side, fine, I can use the complex conjugate because alpha is in the f. So how you can write that? Y plus z comma x by using the फिफ्थ प्रॉपर्टी ऑफ द इनर प्रोडक्ट. यही होते हैं ना फिफ्थ प्रॉपर्टी आपकी. फाइन. नाउ अब आपको अल्फा बाय यूजिंग द प्रॉपर्टीज आई कैन ओपन दैट y कॉमा एक्स प्लस बाय यूजिंग द थर्ड प्रॉपर्टी ऑफ द इनर प्रोडक्ट. अब आप इसका कॉम्प्लेक्स कॉन्जुगेट ले लीजिए. आई कैन राइट एज ए वाई एक्स प्लस का कॉम्प्लेक्स कॉन्जुगेट इज रिमेन द प्लस जेड कॉमा एक्स. फाइन. अब मैं इसको फिर से इस प्रॉपर्टी से रिवर्स कर दे रहा हूं. That will be x comma y and it will be x comma z, and that's the proof of the first part. Similarly, I can use the second same way. I can start from the second property. I can write as a complex conjugate. Alpha will be outside, then it will be y and x, because alpha पहले नंबर पे लिख दिया ना तो alpha बाहर हो गया. Complex conjugate ले लीजिए because alpha is in the f. F may be R or in the C, so I can write as a complex conjugate. Fine. तो इसको फिर से डेफिनेशन लगा देते हैं. So that will be again x comma y, and that's the proof of the second part. Some more examples of the inner product spaces. Whenever you are talking about the Euclidean means f is my r, fine, that means alpha is in my real numbers, लेकिन यहाँ पे alpha कहीं नहीं लिखा, that's why I have written as y bar, because the vector space is my f. Clear? Similarly, if you define corresponding to the complex field z comma w, if you define as the real part of the z and w bar, then it is a inner product. Inner product इसे कब कहेंगे बच्चों हम? when it satisfied my 5 properties, जो मैंने आपको inner product की definition में बताई हैं. If it satisfied all the 5 properties, then we can say these are the inner product. We will prove that it's an inner product space as well. Fine. Next one is, if you consider all are my positive real numbers, fine, then the inner product of the ci into xi is also the inner product. Means if you prove that x comma y is summation of xi yi is the inner product, then if you multiply by any positive numbers, let's say 3 xi yi, it is also the inner product space. You can multiply by 3 by 10, it's again the positive. Yes, it is also the inner product space. But make sure that these are my positive numbers. अगर ये number negative हो गया, then it may or may not be the inner product space. If you define as the continuous real value functions, then the inner product defined from the -1 to +1 is again the inner product space. If you define from the 0 to infinity, find over the set of the polynomials, find then e raised power minus x px qx is also the inner product space. Fine, is an inner product. Clear? मैं इस सबके proof आपको very soon आपको next video में provide जरूर करूंगा. If you define over the complex fields, then continuous valued function of the complex field, then you can write as a complex conjugate. It is also my vector space. Oh, sorry, it is also my inner product. If you define on the matrices, then we can define the inner product called as the Frobenius inner product. As I mentioned you already, A star or the B star is called as the conjugate transpose of the B. Either you can write as a star B or either as a B star. Both have the inner product. How you can representation of the inner product? Suppose V is my finite dimensional vector space and capital B is my basis of the vector space V. Then we can define the inner product by using X transpose AY, where A is my matrix relative to the standard basis and X and Y are my coordinates of the vectors U and V. For example, if I say inner product is defined as X comma Y, fine, I can consider the standard basis is E1 and E2, or E1 I consider as 1 comma 0 and E2 I consider as 0 comma 1. These are standard basis. Then we can define the inner product. Now there are two bases. It's a 2 cross 2. We can define E1. There's a 1 comma 1 element. This is a 1 comma 2 element. It's a 2 comma 1 element. And it's a 2 comma 2 elements. Fine. Now you can find the value of E1. What is the value of the E1? E1 is my 1 comma 0. That means X is my 1 comma 0. Y is my 1 comma 0. So twice of X1 Y1. That is a 2. बाकी सब 0 जाएगा. That gives the 2. Similarly, you can find the E1 and E2. E1, X will be my E1 and Y will be E2. E2 is my 0 comma 1. So if you substitute here, answer will be -1 and so on. Clear? So based on this matrix A, you can define the inner product X transpose A Y. Now look at this case. How you can find the value of the beta if the inner product is given to you. Look at that. It's a standard inner product over the R2. What is the meaning of the R2? If I consider the two vectors x1 and y1, y is my y1 and y2, then what is the standard inner product is? Dot product. Fine. You can multiply them x1 y1, x2 y2. That's a standard inner product of the vector. Your target is to find the vector beta. Fine. It is the elements of the R2. So I can consider the beta is beta 1 comma beta 2 such that the inner product is given to you. Now I can substitute the value. Beta is my x, beta 1 beta 2, x is my 1 comma 2. I can substitute the value. You will get 1 beta 1 plus 3 beta 2 is equal to 3. From the second case, y is my 2 comma 1, 2 beta 1 plus beta 2 which is equal to minus 1. Now can you solve them? If you multiply this number by 3 and subtract them, that will give you the minus 5 beta 1, 0, which is 6. Beta 1 will be minus 6 over 5. Clear? Now you can substitute the beta 1 in one of the equations. You will get the beta 2 as 7 over 5. Therefore, the vector beta is my minus 6 over 5 and 7 over 5. Look at the second case. Your target is to find the inner product. Find where the some vectors are given to you. If you look about these two cases, these are my bases. Fine, of the R2. Then once you have the basis, you can define the inner product by using X transpose A Y. Fine. And how you can find the A? A is my matrix relative to the R1, R1 and so on. Do you know what is the value of the R1 and R1? It's a 2. R1 and R2 is my minus 1 because the inner product is always symmetric. So that's R2 and R1 is same as R1 and R2. That number is my 3. Fine. So therefore, the inner product is X transpose AY. I can substitute the value of the X. That number is X1, X2. The matrix A will be 2, minus 1, 3, and the value of the Y will be Y1, Y2. Now you can multiply them and get the right wave. So your target will be 2x1, Y1 minus 1, x1, Y2 minus 1, x2, Y1 and 3, x2, Y2. और ये आप यहां से भी लिख सकते हो आप. Fine. If you write the first value is x1, this is the x1, x2 and second is y1, y2. Fine. And you can see the first number will be twice x1, y1. ये नंबर क्या होगा आपका? इज अ कॉम्पोनेंट ऑफ द x1 and y2. ये -1 किसका होगा आपका? x2 and y1. And the third component is 3 is x2 and y2. So therefore your inner product is 2x1 y1 minus 1x1 y2 and so on. Look at the next one. How you can prove that the the inner product is basically the inner product space. Similarly, how you can prove that it's an inner product space. इसके लिए क्या प्रूफ करना होगा? इसके लिए आपको ये प्रूफ करना होगा it satisfied my all these 5 properties. Then only you can say these examples are my inner product space. Fine. लेकिन इसको करने से पहले you must try to understand the various properties in detail. फाइन. तो ये लेक्चर आपका हाउ टू प्रूव द इनर प्रोडक्ट स्पेस आई विल अपलोड द नेक्स्ट लेक्चर. उससे पहले तक आप इन लेक्चर को दोबारा से अच्छे से सुन के प्रैक्टिस कर लीजिए. इफ यू रियली वांट टू लर्न हाउ यू कैन प्रूव द इनर प्रोडक्ट स्पेस, लेट मी नो इन द कमेंट बॉक्स. आई विल अपलोड द वेरी सून बेस्ड ऑन योर कमेंट्स. फाइन. आई होप यू कैन शेयर दिस वीडियो विद योर फ्रेंड्स. लाइक एंड कमेंट ऑन द वीडियोस. हैप्पी लर्निंग स्टूडेंट्स. थैंक्स फॉर द वॉचिंग.